So hey guys, welcome to my channel. I'm Santosh and here in my channel I discuss topics from physics and mathematics. As usual, today I'm here with one more new video for you guys, and in this video I'm going to discuss two important quantities related to Coulomb's law, which are absolute permittivity and relative permittivity. Guys, here in this video we'll first see the definitions of these quantities, and then we'll also see how these quantities affect the force between 2 point charges which are placed in different mediums. And at the end of this video, we will solve few numericals related to this topic. But before starting the discussion, I request you guys to watch my previous video on Coulomb's law, because this is the continuation of that video. Guys, the Coulomb's law states that the magnitude of force between any 2 point charges is directly proportional to the product of magnitude of their charges and inversely proportional to square of distance between them. And this law also gives us the expression for calculating the magnitude of force between 2 point charges, which is F is equal to K mod of Q1 Q2 divided by R square. Here Q1 and Q2 are 2 point charges and R is the distance between them. The term K here in this expression is Coulomb's constant, and we have discussed in our previous video that the value of K changes from medium to medium. Guys, this entire video we are going to discuss about this term K. So without wasting much of our time, let's get started. Guys, let us begin our discussion with a very simple example which will set the context for today's discussion. Imagine you and your friend playing in the ground. You have a ball and you are playing the catching game, in which you throw the ball towards your friend, he catches it, and then he throws the ball towards you, then you catch it. A very simple game. In this game, when you are throwing the ball, you are exerting the force on that ball. Then the ball will move through the air and reach your friend. When your friend receives that ball, he will experience almost the same force that was exerted by you on that ball. In other words, you exert the force on your friend through that ball. Now you play that game for a while and then get bored. Then both of you decide to play that game inside the water. Then you get into the water and stand away from each other at exactly the same distance that you are standing on the ground. Then you throw the ball towards your friend with the same force. You throw the ball towards your friend with the same force. Then the ball moves through the water and reaches your friend. My question is, when your friend collects that ball, will he experience the same force or little less force? And the answer is, your friend will experience less force compared to the force that you have exerted on the ball. The reason is, when ball moves through the water, due to its viscous force, ball loses its speed. When it reaches your friend, he will experience the less force compared to the force that you have exerted on the ball. Now, what do we understand by this example? From this example, we can understand that the medium plays a very important role in the interaction between two bodies. When you and your friend were playing in the ground, air was the medium. Then your interaction was not getting affected by the air. When you moved into the water, the interaction between you and your friend was affected greatly by the water. So here water opposed the interaction between you and your friend. Guys, imagine the same thing in the case of charges as well. Consider two charges Q1 and Q2 separated by some distance d, placed in the air. Let F be the force experienced by the charges Q1 and Q2. Now what you do, you take these two charges and place them inside the water. Now, if you measure the force between these two charges inside the water, it will be different from the force that was experienced by these two charges when they were in the air. Now the point that I am trying to make here is, the force between two charges depends not only on the charge and distance, it also depends on the medium in which two charges are placed. Guys, we know that this expression given by Coulomb's law gives us the magnitude of the force between 2 point charges. Now the question is, which term in this expression represents the dependency of force on the medium? We know that force between two charges depend on the medium in which they are placed. So which term in this expression shows that dependency? The answer to this question is K, which is also known as Coulomb's constant. Guys, K is also expressed as 1 by 4 pi epsilon. Here epsilon is the permittivity of the medium in which charges are placed. Permittivity is the property of medium which opposes the interaction between two charged bodies. It is the property of the medium which opposes the interaction between two charged bodies. Now, to understand more about this property, let us look at the definition of permittivity. Permittivity is the measure of polarizability of a medium in response to the applied electric field. It is the measure of polarizability of a medium in response to the applied electric field. In simple words, it is the ability of medium to oppose the electric field created by other charges. It is the ability of a medium to oppose the electric field created by the charges. Guys, to understand the meaning of these statements, we need to understand how exactly two charges interact with each other. For that, let us consider two charges Q1 and Q2 placed in the vacuum. We know that Q1 exerts force on Q2 and Q2 exerts force on Q1. But what we don't know is how exactly this interaction takes place. Because the interaction between Q1 and Q2 happens without Q1 and Q2 coming in contact with each other. They interact with each other without coming in contact with each other. And this kind of interaction is also called as action at a distance. Now, to explain these kind of interactions, scientists came up with a concept of field, according to which each charge will create something called field in its surrounding space, and it interacts with the other charges through that field. Each charge, let's say Q1 will create something called field in its surrounding, and when other charges like Q2 come in that field, they experience force because of that field. So the interaction between Q1 and Q2 is explained using the concept of field. Q1 creates its field and that field exerts force on Q2. Similarly, Q2 will also create the field and that field will exert force on Q1. Guys, here you need to make note of two important things. First one, the field created by charge Q1 will not affect the Q1 itself. Similarly, the electric field created by charge Q2 will not affect Q2 itself. Second one, the electric field is the vector field, which means the value of field at each point in the space can be represented by a vector having its own magnitude and direction. Now, coming back to our example where Q1 and Q2 exert force on each other. Here, to exert force on Q2, Q1 will produce its own field. So Q1 will produce its own field and that field exerts force on Q2. Now the field of Q1 is represented by arrows here. So here each arrow will show the magnitude of the field at that point, and then the direction of arrow shows the direction of that field, right? Now what I will do, I will take these two charges and place them in the different medium. I will change the medium from vacuum to some other medium. Now what will happen is, the new medium will oppose the electric field created by these charges. The new medium will oppose the electric field created by these charges. So what happens is, the strength of the electric field will reduce. If the strength of electric field reduces, then the force exerted by that field on the other charge will also reduce. Which means, if the medium has capacity to oppose the electric field, then medium will reduce the interaction between these two charges. Thereby, the force experienced by these two charges will also reduce. In other words, if the medium has high permittivity, then it will oppose greatly the electric field created by these charges, then the force between these charges will also reduce. So, higher the permittivity, the lower the force experienced by these charges. Guys, it is found that vacuum is the medium which has the lowest value of permittivity. And the permittivity of the vacuum is represented as epsilon naught, which is equal to 8.854 into 10 raised to minus 12 Coulomb square per Newton meter square. Which means two charges will experience the highest force when they are placed in the vacuum compared to the other mediums. Now, using this value of epsilon naught, if you find out the value of Coulomb's constant, it will roughly come out as 9 into 10 raised to 9 Newton meter square per Coulomb square. So, this is the value of Coulomb's constant for the vacuum. Guys, now that we know what permittivity is, let us now see what relative permittivity means. Guys, the relative permittivity is defined as the ratio of permittivity of a given medium to the permittivity of vacuum or a free space. It is defined as the ratio of permittivity of a given medium to the permittivity of vacuum or a free space. And this quantity is represented by symbol epsilon r. From its definition, epsilon r can be written as epsilon r is equal to epsilon divided by epsilon naught. Here epsilon is the permittivity of a given medium and epsilon naught is the permittivity of vacuum or a free space. Guys, what does this ratio signify? It tells us that how large is the permittivity of a given medium compared to the permittivity of free space or vacuum. We know that if the permittivity of the medium is higher, then the force between two charges will be lower. Or in this case, we can say that if the relative permittivity of the medium is higher, then the force between two point charges will be lower. Now, rearranging the terms in this expression, we can write epsilon is equal to epsilon r into epsilon naught. Now, using this value of epsilon in the Coulomb's law, we get the magnitude of force F is equal to 1 by 4 pi epsilon r into epsilon naught into mod of q1 q2 divided by r square. And clearly from this expression, you can see that if the value of epsilon r is higher, then the value of force will be lower between 2 point charges. And the value of epsilon r will be minimum when the medium is space or vacuum. So epsilon r for the vacuum or space is 1, and that is the lowest value of epsilon r. And for all other mediums, the value of epsilon r is greater than 1. And here we have a table which gives us the value of relative permittivity for some important mediums. For vacuum, as I said, it is 1, and for air it is very close to 1, but it is not 1. It is 1.0005, and for oil it is 2.3, and for glass it lies between 4 to 10. For different kinds of glass it will be different, so it lies between anywhere from 4 to 10, and for water it is 81. Guys, now in the final part of this video, let us solve few numericals related to this topic. Question number 1. Two charges q1 and q2 are placed in the vacuum at a distance d, and force acting between them is 5 Newton. If the medium of dielectric constant 2 is introduced between them, then what will be the new force between these two charges? Guys, first let us see what is given and what is asked. Here in this question, they have given us two charges q1 and q2 separated by some distance d placed in vacuum. The medium is vacuum. And they have also given us the force experienced by these charges. That is, force experienced by q1 and q2 is equal to 5 Newton. And what they have done after this, they have placed these charges in the medium, that is another medium whose dielectric constant is 2. What is dielectric constant? It is the relative permittivity of that medium. So they have changed the medium from vacuum to another medium. Here the relative permittivity of the medium is 2. Now in that medium, we need to calculate the force experienced by these charges. Now the magnitude of these charges is same and the distance between them is also same, but the force between them will be changed because of the change in the medium, and we need to calculate the new force of attraction or repulsion between those charges. Guys, if you observe that diagram, we have in the first case the two charges q1 and q2 are placed in the vacuum. For vacuum, the value of epsilon r is equal to 1, that is relative permittivity of vacuum is equal to 1. Let F1 be the force experienced by q1 and q2 in the vacuum. So using Coulomb's law, I can write the expression for F1. F1 is equal to 1 by 4 pi epsilon r epsilon naught into mod of q1 q2 divided by d square. D is the distance between q1 and q2. Now here epsilon r is equal to 1, so it will become 1 by 4 pi epsilon naught mod of q1 q2 divided by d square. This is the expression for force experienced by q1 and q2 in the vacuum, and the value of F1 is given, which is 5 Newton. So we will use that value later. In case 2, which is new medium, when the charges are placed in the new medium and the dielectric constant of that medium is also given, we have epsilon r is equal to 2 for that medium. Now writing the expression for force between these two charges in that medium, we will have F2 is equal to 1 by 4 pi epsilon r into epsilon naught mod of q1 q2 divided by d square. And if I bring epsilon r out, I will have 1 by 4 pi epsilon naught mod of q1 q2 divided by d square. These two are same. If you observe, these two are same. This is exactly equal to the F1. So I can write F2 is equal to 1 by epsilon r into F1. F1 here is the force experienced by these two charges when they are kept in the vacuum. So F2 will be equal to 1 by epsilon r times 5 Newton. Epsilon r is 2 for this medium, so F2 will be 1 by 2 into 5 Newton, which is equal to 2.5 Newton. So force experienced by q1 and q2 when they are placed in the new medium is equal to 2.5 Newton. Question number 2. Two charges Q1 and Q2 are placed in vacuum at a distance d and force acting between them is 5 Newton. If the medium of dielectric constant 2 is introduced between them and the distance between them is doubled, then what will be the new force acting between these two charges? Guys, again in this question also they have given us two charges Q1 and Q2 separated by some distance d, and these charges are placed in the vacuum, and the forces between these two charges is given, which is equal to 5 Newton, which means force experienced by Q1 is 5 Newton and force experienced by Q2 is also 5 Newton. Now what they have done, they have moved these charges from vacuum to another medium, and the dielectric constant of that medium is 2. That is, the relative permittivity of that medium is 2. Now they have also changed the distance between the charges in that medium. Initially the distance between charges was d. Now the distance between these two charges is doubled, which is equal to 2d. Now we need to calculate the new force between these two charges. Now certainly the force will change because of the change in distance as well as change in medium, and we need to calculate the magnitude of that force between Q1 and Q2. Guys, if you observe the diagram, in case 1 we have two charges Q1 and Q2 placed in the vacuum, and for vacuum the value of epsilon r is 1, and from given we have the force experienced by these charges is equal to 5 Newton. But if I write the expression for this force F1 using the Coulomb's law, I will get F1 is equal to 1 by 4 pi epsilon r into epsilon naught mod of Q1 Q2 divided by d square. D is the distance between two charges. Here epsilon r is equal to 1, so F1 will become 1 by 4 pi epsilon naught mod of Q1 Q2 divided by d square. Let's call this as equation number 1. Now in the second case the medium is changed. We have new medium whose relative permittivity is equal to 2, and in this case the distance between the two charges is doubled. The distance was d then, and now in this case it will be 2d. So if I write the expression for force experienced by the Q1 and Q2, I have F2 is equal to 1 by 4 pi epsilon r into epsilon naught mod of Q1 Q2 divided by 2d whole square. 2d is the distance between Q1 and Q2 in this case. So this will be equal to 1 by 4 pi epsilon r into epsilon naught mod of Q1 Q2 divided by 4d square. Now if I take epsilon r and 4 out here, I will get F2 is equal to 1 by 4 pi epsilon r in the bracket 1 by 4 pi epsilon naught mod Q1 Q2 divided by d square. If you observe here, these and these are same. These two are same. So this can be replaced by force F1. So F2 will be equal to 1 by 4 epsilon r into F1. If I substitute the value of epsilon r and F1 here, I will get F2 is equal to 1 by 4 into 2 into 5 Newton, which will be equal to 5 by 8 Newton, and that will be equal to 0.625 Newton. So this is the new force experienced by the Q1 and Q2 when we change the medium and also the distance between them. Guys, with this we come to the end of this video. If you like the video, please hit the like button and share this video with your friends, and finally don't forget to subscribe to my channel. So guys, thanks for watching and stay tuned for